Hi, hello, welcome to Homeschool for Understanding Quadrilaterals. In this session, we are going to study about the introduction about all these curves. It might be polygons and what are all the types of polygons. The introductory part we are going to see in this session. Let's start our session with a simple curves. So, children, you might be having some idea. Suppose a paper is a plain surface. Let me see, this is a plane surface. On this plane surface, when I try to join number of points without lifting my chalk piece, then we get a plane curve. What we said? It is a plane curve. And one more. Suppose I may take like this or like this. So here you can see carefully like this. If I try to join without lifting chalk piece, I have drawn this. Right? This is also a plane curve. And now if I try to join one more point like this, what has happened now? I have done here retracing the line. Retracing the line means again this line touching the line which I have drawn before. Then what I can say, this type of a curve, it is not a simple curve. It is not a simple curve. This is a simple curve. This is not a simple curve. So once again, what is a plane curve or a simple curve? When we start joining the points from one point, it should be ending at the other point or same end point it can touch. But it should not be retraced. If it is retraced, it is not a simple curve. Then this is a simple curve. And one more word you need to understand here. That is simple open curve, simple closed curve. Look here, this curve is a simple curve and it is open. Yes, it is not closed, it is open. Suppose if I try to join this one here, then this is a simple closed curve. In simple closed curve, it will be having two regions, interior and exterior. Okay, interior region and exterior region it will be having. Simple curve and this is your simple closed curve. This is not a simple curve. Okay, suppose if I draw like this, simple curve which is open or simple curve which is not closed. Right? First thing you need to understand these curves. Then we can go with the polygons. Okay, once again, when you join a number of points without lifting a pencil from the paper, then we call it as a plane curve or a simple curve. And you should not retrace any portion of the drawing other than the single point. Then we call this as a plane curve. We should not retrace any other point. If we touch the whole drawing, what you can say? It is not a simple curve. So you can see some pictures and you need to match these two. Here you can see figures and here you can see the type. Just try to say this. Okay, this is line segments. Okay, if I start my chalk piece, look here children, what am I doing? Yes. It is a simple curve. Is it closed? No, it is not closed. Simple curve which is not closed. Next one. Let me start from one end point. Okay. Yes, now what it is doing here? It is passing through the before drawing. So it is not a simple curve. It is not a simple curve and it is also not closed. Next one, if I start from any point, Look here, how am I tracing? Yes. Started from the point and ended at the same point. So it is a simple closed curve. This is a simple curve and it is closed, having interior and exterior regions. Next one. Yes, look here. First, and now it touches the old drawing. Before what I have drawn, that line it is touching and passing through that line. So you can say it is not a simple curve. Okay, now try to match here. Which are the simple curves you can see? Yes, simple curve. Yes, this is also simple curve. And here these matchings, you can get 2 or 3 answers also, no problem. You cannot say only one answer. These figures may sync with same answer. This is a simple curve and this is also a simple curve. And next, a closed curve that is not simple. Closed curve that is not simple. Where is a closed curve you can see other than this? This is a simple closed curve. So this statement you won't get for this. A closed curve that is not simple. Look here. This is a closed curve and it is not simple. Okay. Next one. Simple curve that is not closed. Where you can see here simple curves. Here and here. Here simple curve it is closed. This is a simple curve which is not closed. So for this answer is this one. Okay. Next. Not a simple curve. Not a simple curve. Where it is? Yes. Once again let us see the curves here. See here this is a simple curve which is not closed. This is not a simple curve and this is a simple curve which is closed. And this is not a simple curve but it is closed. So what are the answers you have written for this? It is a simple curve. It is a simple curve that is not closed. A closed curve that is not simple. This is a closed curve but it is not simple. Simple curve that is not closed. This one. And not a simple curve. This is not a simple curve. Polygons. What are polygons? A simple closed curve made up of only line segments are called as polygons. What is a polygon? It is a simple closed curve and these simple curves are made up of line segments. Then only we call them as a polygons. What is a polygon? A polygon, it is a closed curve made up of line segments. Line segments. What is a line segment? Having 2 endpoints. Let the point be AB. Now I say this, AB is a line segment and you may write this as AB. Like this also you can write. Okay. Now what is this closed curve? You have seen now simple curve, open curve, closed curve, all this we have seen. These are the simple closed curves. These closed curves are formed by line segments. And you can see here curves that are polygons, curves that are not polygons. Look here, first figure. 1, 2, 3, 4. Okay, you can see here 1, 2, 3, 4 line segments it have joined and you got some figure. What type of a figure it is? It is a simple closed curve. Look here. Simple closed curve. Why it is simple? From one point it have started and ended at the same point. This is a simple closed curve. And look here, this is rectangle and you can start from one point and you can end from that point. Or if you consider any one point, it can have 2 directions. Either it can move this side and meet here or either it can start from here and again it can meet here. Any point, if you consider, it can go in two directions. Any direction if it travels, again meeting at the same point. Okay, this is also a simple polygon. What is this? Curves that are polygons. This simple closed curve is made up of only line segments, so it is a polygon. And this one also, as I have said, it can move in any two directions, and this is also a simple closed curve and it is made up of line segments. It is also a polygon. You can see here, this is also sleeping rectangle, you can see, right? So from here, if you start, again it can meet at the same point. Just we draw this figure. Very simple. Simple closed curve with line segments. Then we call this as a polygon. Curves that are polygons. Next, curves that are not polygons. What is this? All are made up of line segments. Why we can say it is not a polygon? See, observe here, this is not a simple curve. Why it is not a simple curve? If it is started here, so once if it is moving in this direction, then again it is overlapping on the before line. So it is not a simple curve. Though it is made up of line segments, it is overlapping. Suppose if you trace with a pencil, if you are able to do without lifting a pencil, then that figure is called as a simple closed curve. When we are drawing, it is overlapping on the before line what we have drawn. So it is not a simple curve, and this is made up of line segments, but it is not closed. It is open here. Though it is closed, it is open here. Therefore, it is not a polygon. Let's see the next figure. See here, if you start anywhere, if I start tracing this, like this, if I start, yes, now it is touching the before line, moving like this, again retracing. Retracing is not allowed. When you are tracing, again it is overlapping on the drawing what we have done before. And one more, this is here, if you see this part, it is not closed, right? It is not a simple curve and it is not a polygon. Then look here, this is also made up of line segments. 1, 2, 3, and here 4, 5. Yes, it is a simple curve. Simple curve. I am not using the middle word. Simple curve made up of line segments. But is it closed? No, it is not closed. Right? A simple closed curve made up of line segments, we call it as a polygon. It is not closed, so we say it is not a polygon. Okay, curves which are polygons, curves which are not polygons. Classification of polygons. We classify the polygons by the number of sides or vertices. Look here, I hope every one of you know what are sides and what are vertices. Just see here, this is the vertices. 1, 2, 3 vertices it have, and 3 sides. 1, 2, 3. We classify the polygons according to the number of sides, or you may say vertices. Look here, if you have 3 sides, which type of figure you can draw? If you have 3 sides, 3 line segments, if it is joined, you get a triangle. What is that? You get a triangle. Sample figures you can see here. Classification and number of sides. If you have 3 sides, you can get a triangle. If you have 4 sides, quadrilateral, and this will be like this. Let us see. Count the sides. 1, 2, 3, 4. Let's count the vertices. 1, 2, 3, 4. 4 vertices and 4 sides. And it is also a polygon. How you can see? It is a simple closed curve with line segments. All these are all the polygons. And these are all closed curves with the line segments. 3 sides, triangle. 4 sides, quadrilateral. And if you have 5 sides, what is the name we call it? It is a pentagon. You can see here 1, 2, 3, 4, 5 sides. If you have 6 sides, hexagon. 7 sides, heptagon. 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. Look here, in all these figures, you can observe the sides. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, number of sides, we see the figure here. According to the number of sides, we see the name of the polygon. This is the way we classify polygons. Let's see once again. If a polygon having 3 sides, it is a triangle. 4 sides, quadrilateral. 5 sides, pentagon. 6 sides, hexagon. 7 sides, heptagon. 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. Like this, n sides, n-gon we call. Like this, dodecahedron, octahedron, many you will be having. According to the number of sides, the name of the polygon, it depends. For any polygon, you can say that interior, exterior. Inside closed region is called as the interior region, and outside it is a never ending, it is a exterior. Look here, suppose if I take a triangle, only this part I call it as interior. Then for that triangle, exterior. What is this? Other than this triangle, remaining part is all exterior region only, right? It is a simple closed curve, but the line segments are all called as a polygons, and these are all the closed figures having interior and exterior, and this classification is done according to the number of sides what they have. So interior and exterior. Suppose how we say their sides and vertices. Look here, suppose if I consider triangle, I say AB, BC, CA are the sides. A, B, C are the vertices. And if I take a quadrilateral, A, B, C, D, what are the sides identified, children? A, B, B, C, C, D and D, A. Like this, we identify the sides, and A, B, C, D are the vertices of this quadrilateral. So last time we are going to identify the polygons. Okay. If they have 3 sides, which type of a polygon it is? Triangle. 4 sides, quadrilateral. 5 sides, pentagon. 6 sides, hexagon. 7 sides, heptagon. 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. Let's know about the diagonals. What is a diagonal? A diagonal is a line segment connecting two non-consecutive vertices of a polygon. We know vertices, but what is a consecutive and non-consecutive word? Look here. Suppose if I take A, for A, B is consecutive. Consecutive, continuous. A after you get B. And though it is a closed figure, when you start tracing this, Before A, we get D also. For A, B is consecutive and D is also consecutive. A diagonal is a line segment connecting two non-consecutive vertices. For A, B and D are consecutive. Then for A, what is a non-consecutive vertices? Non-consecutive vertices for this figure is, for A, C is non-consecutive vertices. Therefore, AC is a diagonal. Similarly, for B, A and C are consecutive. D, which is opposite to B, here you can see D. Then from B to D you can join. Therefore, AC and BD are the diagonals. AC and BD are the diagonals of four-sided polygon. What it is? It is a quadrilateral. Okay, understand carefully. Diagonals. A diagonal is a line segment joining two non-consecutive vertices of a polygon. Let's see the next figure. 1, 2, 3, 4, 5. 5 sides you have. Which type of a polygon it is? Pentagon. Yes. So, how many diagonals you can draw for this? Look here. Suppose if I start with P. For P, Q and T are consecutive. Non-consecutive set. So, I may draw PR and PS are the diagonals. Other than these two vertices, you can join for other vertices. Next, coming to Q. P and R are consecutive for Q. Consecutive vertices for Q. For Q, non-consecutive. Look here carefully. Yes. What are the diagonals? QS and QT are the diagonals here. Then for R, Q and S are consecutive. So non-consecutive RP, RT I will join. Yes. Already two diagonals there from S and from T also two diagonals there. So same is the diagonals here. PR, PS, QT, QS, RP already there, RT, SQ, QS it is there, SP, PS it was there, and TQ, QT there, TR, RT there. So how many diagonals you can see here? 5 sides, 5 diagonals you can draw here. Okay, here 4 sides, only 2 diagonals. And then next figure. 1, 2, 3, 4 sides you have. So it is a closed polygon having 4 sides. You can say it as a quadrilateral. But now where are the diagonals? L, M, N, K. So now show me diagonals here. For L, M and K are consecutive. Non-consecutive means N. So look here, as you have already in your textbook, LM is joined and MK is joined. Why? For M, L and N are consecutive. And MK is not a consecutive. So we have joined MK. MK is a diagonal. Is LN is a diagonal? No, it is not a diagonal. Diagonals will be inside the polygon. Diagonals will be interior of a polygon. Exterior of a polygon, you cannot say it as a diagonal. So, this is not a diagonal. And whereas you have one question there. Is PQ a diagonal or DC a diagonal? No, DC is a side. PQ is also a side. And what about LN? LN is a diagonal? No, it is not a diagonal. Though you may say it as a diagonal, but it is not in the interior part of the polygon. It is the exterior part of a polygon. I cannot say this as a diagonal. So as it is having 4 sides, Okay. When we get a diagonal is a line segment connecting to non-consecutive vertices of a polygon. Though if you join non-consecutive vertices, this line segment will be outside the polygon. So I cannot consider it as a diagonal. I may consider KM as a diagonal for this polygon. Okay, is it clear? Let's see the types of polygons. In types of polygons, we can classify it as convex polygons, concave polygons, regular polygons, irregular polygons. Let us see first one, convex polygons. What are convex polygons? You can see the figures here. These are all convex polygons. What you can see by this? What do you mean by a convex polygon? In convex polygon, all the angles will be less than 180. All the angles will be less than 180 degrees. These type of polygons are called as convex polygons. Let's look here. Yes, it is acute. Yes, you can see here all the angles are less than 180 degrees. Look here. Yes, you can see this one. All the angles. This is a six-sided polygon. Convex polygons are those polygons having all the angles which are less than 180 degrees. In this polygon, each angle will be less than 180 degrees. Those polygons are called as convex polygons. I repeat, convex polygons are those polygons each angle is less than 180 degrees. Next, coming to concave polygons. Any one angle is more than 180 degrees. Any one angle is more than 180 degrees. Observe the figure here. Which angle is more than 180? Yes, this angle is more than 180 degrees. This is a concave polygon. And in this, if you consider this angle is more than 180. And I can see these are all the simple figures or a simple curves, and these are all the polygons. These are all the closed figures and they are polygons. And now in this concave polygons, these are also polygons, but the line segments only they have ended, and it is also a closed curve, right? In these figures, any one angle is more than 180 degrees. This angle is more than 180 degrees. Then it is a concave polygon. And here you can say this angle is more than 180. And here it is more than 180 degrees. Any one angle in the given polygon, if it is more than 180 degrees, then we can say it as a concave polygon. And if in a polygon, if all the angles separately, if you see, each angle will be less than 180 degrees, then those type of polygons are called as convex polygons. And any one angle is more than 180 called as concave polygons. Next, coming to regular polygon. What is a regular polygon? A polygon is both equilateral and equiangular are called as a regular polygons. What are regular polygons? Equilateral and equiangular. Equilateral and equiangular. What do you mean by this? Equilateral. All sides are equal. All sides are equal. Equiangular. And you can see here, children, the small line which I have drawn. See the small mark what I have done. It shows that these line segments length is equal. Look here, I have taken an example of a triangle ABC where AB equal to BC equal to CA. all three sides are equal, we call it as equilateral triangle. Equiangular, look here, angle A, angle B, angle C. The small tiny curve what you can see here, it indicates angle A equal to angle B equal to angle C. All the three angles are equal. Then I can say that this figure or this polygon is equilateral and equiangular. This polygon is equilateral and equiangular. So those type of polygons are called as regular polygons. Shall we take one more example? Let me take here square. Four-side quadrilateral. I have taken here square. Square, what happens here? All angles are equal. If all angles are equal, what it is? It is equiangular. Square, all sides are also equal. You may take a double line or a single line. Like this, you can take any way. This square is equiangular and equilateral. All sides are equal. All angles are equal. Suppose if you take any other figure. Let me take a rectangle. Let me take a rectangle where these two sides, opposite sides are equal. These two sides are equal. A, B, C, D. Observe here carefully. It might be, all angles might be perpendicular to each other, means 90 degrees. All angles are equal. It is equiangular. But is it equilateral? No, it is not equilateral. Only the opposite sides are equal. AD equal to BC and AB equal to DC. But what is the condition for regular polygon? All sides and all angles must be equal. If they are not equal, then what you can say? Those are called as irregular polygons. This is a polygon and it is a irregular polygon. Any polygon which is not regular is called as a irregular polygons. We can take many examples like this. Though angles are all equal, sides may not be equal. Though sides are all equal, angles may not be equal. So you can take any other figure like this. So you can say that these two angles are equal and these two sides are equal and these two sides are equal and these two angles are equal. You can see here, immediately you can see, if these two sides are equal means this side is not equal to this side. These two sides are equal and these two angles are equal, these two angles are equal, right? A pair of angles equal and pair of sides equal. Then I can say it is a irregular polygon. What is the rule for regular and irregular polygon? The polygons which are not regular are called as irregular polygons. Let's repeat the board again. Types of polygons we have seen. What are convex polygons? The angles inside, interior angles. What angles I am going to talk here? All about the interior angles. The angles are less than 180. This angle is less than 180. Every angle in a polygon is less than 180 degrees. What is a concave polygon? Any one angle is more than 180, then those type of polygons are called as concave polygons. Regular polygons, a polygon having both equilateral and equiangular, then that type of polygon is called as a regular polygon. A polygon is not regular, then we call it as a irregular polygon. Now we are going to learn about angle sum property of a polygon. Angle, which angle we are talking here? Interior angles. Interior angles means this and this. The sum of the interior angles of a triangle is how much? How can we know this? It is easily remembered by a tiny formula. Sum of interior angles of a polygon. It may be any polygon. It may be triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, any polygon. Same formula you can apply. What is that, children? N minus 2 into 180 degrees. What is n? Number of sides containing the polygon. How many sides that polygon contain? That is your n value. Let's see first polygon. Having 3 sides, then what is the name of this polygon? Triangle. What is the sum of the interior angles of this triangle? How can we know? N, 1, 2, 3. N value is how much? N is equal to 3. 3 sides you have, right? Formula 3 minus 2 into 180 degree. 3 minus 2 is 1. 1 into 180 degree is equal to 180 degree. Therefore, I write it here. Angle A plus angle B plus angle C is equal to how much? 180 degrees. Okay, just you can remember the sum of the interior angles of a triangle is equal to 180 degrees. Let's see the next polygon. Having 4 sides. If it has 4 sides, what is that one? It is a quadrilateral. Quadrilateral. A, B, C, D. A, B, C, D is a quadrilateral. What is the sum of interior angles of this quadrilateral? Look here. Angle A plus angle B plus angle C plus angle D is equal to. What is your n value? How many sides you have? 4. How many sides? 4 sides. Okay. Yeah, formula. Sum of the angles. I write the angles. Angle A plus angle B plus angle D is equal to n minus 2 into 180. N value is 4. 4 minus 2 into 180 degrees. That will be 4 minus 2 to 2 into 180 degrees. 2 into 180 it will be 360 degree. Polygon having 4 sides, the angle sum is 360 degree. Similarly, we can go with the next polygon. What is the next polygon? How many sides it has? 1, 2, 3, 4, 5. 5 sides. What is the name we call? Pentagon. Right? So let me mark here. P, Q, R, S, T. Apply angle sum property here. N is equal to, what is N? How many sides you have? 5 sides you have. N is equal to 5. And all angles, angle P plus angle Q plus angle R plus angle S plus angle T. 5 angles, right? 1, 2, 3, 4, 5 angles is equal to N minus 2 into 180. What is your N value, children? 5. 5 minus 2 into 180 degrees. 5 minus 2 will be 3. 3 into 180 degree. That will be 540 degrees. It's very easy, no? Angle sum. The sum of the interior angles of a pentagon is equal to 540 degree. Similarly, you can go with the next polygon. What is that polygon? How many sides it has? 1, 2, 3, 4, 5, 6. 6 sides. What it is? Hexagon. Okay. N is equal to 6. A, B, C, D, E, F. Angle sum property. Angle A plus angle B plus angle C plus angle D plus angle E plus angle F is equal to N minus 2 into 180 degree. How many sides you have? 6 sides. 6 minus 2 into 180. 6 minus 2 is 4. 4 into 180 degree. 4 8s are 32. 4 1s are 4 plus 3, 7. So angle sum property of a hexagon. The interior angle sum is equal to 720 degree. Right? Is it clear? Or another way you can find out the sum of angles. Look here, what is that another way? Number of triangles into 180. Number of triangles. I can see it is only in one polygon which is having 3 sides. Right? So this is only one polygon we feel. So in triangle further I cannot draw. So how many triangles having for this polygon? Only one. 1 into 180 degree, it will be 180 degrees for this triangle. Next, let me go with the quadrilateral. Let me take any one point from A, non-consecutive point I am going to join. How many triangles you got? 2 triangles, right? Now, 2 into 180 degree, that will be 360 degree. Easy technique, children. Next one. Take any one point. I take P. You can take T, Q, S, any one point. From this, I try to join non-consecutive points. 1, 2. That's it, no? Okay. I have joined, but that is not the number of triangles. Look here. 1, 2, 3. How many triangles you got? 3 triangles. 3 into 180 degrees is equal to 540 degrees, your answer. And next one, take any one point. Let me take A, AE, AD, AC. How many triangles you can get here? 1, 2, 3, 4. 4 into 180, 720 degrees. 4 into 180 degree is equal to 720 degrees. Understand these polygons carefully, children. It is very easy to find the angle sum of any polygon. Suppose if you know the sides, suppose you have 10 sides. If they say, what is the angle sum? If they ask you 10 minus 2, 8. 8 into 180, you can say. Right? Very easy technique. You can apply this formula, or you can go with this triangle into 180 also you can go with. Right? How many triangles you can draw in a given polygon? That many triangles into 180. Next point we need to remember. Sum of the measures of the external angles of any polygon, it may be, children, any polygon. But internal angles, interior angle sum is different. It is not fixed. But whereas exterior angle sum is fixed. Exterior angle sum is how much? For any polygon it will be 360 degrees it seems. Where is exterior angle here? Suppose, let me draw the exterior angle. Let me extend the angles like this. So now you can get an angle. This angle plus this angle, 1, 2, 3. If I write angle 1 plus angle 2 plus angle 3 is equal to 360 degrees. The exterior angles of a triangle ABC, the angles sum will be 360 degrees. Suppose if you know any two angles and if you don't know another angle, just directly substitute that and you can get the third angle. Similarly, how many sides you have here? 1, 2, 3, 4, 5, 6. 6 sides. It is a hexagon. This is a polygon and what is its name? Hexagon. Where are the exterior angles? Let me extend like this. Okay, this angle plus this angle plus this. If I write 1, 2, 3, 4, 5, 6. Angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 is equal to 360 degrees. 360 degrees. The sum of the exterior angles of any polygon is equal to 360 degrees. By applying this statement, you can find the missing angles. With this, we are going to end our session of mathematics basics. In our next session, we are going to continue with another new basics. Thank you.